Everyone understands the value of plastics to our society, health, and standard of living. The real issue is the waste plastics problem and how to develop a society that involves a circular plastics economy for these important materials. So our view in our circular plastics service, we've modeled municipal solid waste, which is the primary area where the majority of waste plastics find their way after use. And we model that going out to 2050 on a global basis. The methods we use to model that involve standard of living, GDP per capita, and also population growth. And unfortunately, we've concluded that the problem of waste plastics volumes is going to get worse before it gets better. In fact, we project that the municipal solid waste volumes are going to grow from about 2.1 million metric tons 2.1 billion metric tons in 2020 to about 3.6 by the time we get to 2050 on a global basis. Of that, probably around 9% of that volume is going to be plastics waste. And unfortunately, the majority of that is going to be outside of the developed regions of the US, North America, Europe, and even China. It's going to show up in Southeast Asia, Africa, and India. So that'll be the source of waste plastics that need to be managed. And as I said before, the issue of waste plastics volumes, in our estimation, is going to pose more of a problem in the future than it does currently today. There have been a large number of projects announced for waste plastics recycling. Many of them are for mechanical recycling processes, and then a number for what's called advanced recycling. The mechanical recycling processes are the more simple, lower capital costs, lower operating costs, low energy consumption, but are limited by the need to have a high quality, homogeneous raw product coming in as waste plastic, typically adapted for rigid containers like milk bottles and other rigid packaging. The advanced technologies are able to handle a broader spectrum of waste plastics and different product forms, such as film and flexibles, which are hard to recycle in a mechanical system. We're tracking, as part of the Circular Plastics Service, projects out to 2028, 2029 that total about 13 or 14 million metric tons of waste plastics capacity. That sounds like a large number, but it really is relatively small in the context of the total volume of waste plastics that we're dealing with. These advanced recycling technologies are primarily based on pyrolysis, and that generates a pyrolysis oil that can be upgraded and used to feed steam crackers that provide the ethylene feedstock for a new round of virgin polymers. So I think that's a really interesting concept. However, the advanced recycling that we're talking about right now are what we call demonstration scale proof of concept projects, 10, 20, 50,000 metric tons per year. And we really need to get projects that are an order of magnitude larger than that in order to make a significant dent in the waste plastics issue going forward.